Okay, so my zero period isn't meeting today because of PSCTs, so I'm forced to record today's lecture so they don't fall behind. Today we're going to be talking about um, standards in stoichiometry ST6 and ST7 for anybody who's watching this who might not know what this is about. Um, Today, basically, what we're going to be talking about is chemical changes and also physical changes. Okay, I'm Mr. Sakaguchi, and here we go. So, if we look at chemical reactions, we can get a lot of information from it. So, let me write out a simple reaction that we can talk a little bit about here. So, let's say we are making ammonia from hydrogen and nitrogen gas. So, this would be the chemical equation for that. And of course, we need to balance this, and we balance this by putting a 2 here and a 3 here. But let's talk a little bit about what's actually happening here. Now, what's happening during this reaction is chemical changes. And so what is a chemical change? What's happening is on this side of the equation, the reactant side, bonds are broken. In other words, we basically have to pull apart the nitrogen from itself and the hydrogens from itself to create the ammonia, or the NH3. And so what happens on the right-hand side is bonds are simply formed. Okay? And this is the essence of a chemical reaction. We're breaking bonds and we're forming new ones. So that is what a chemical change is. Okay? In a physical change, you're changing the state of matter, but the composition of the substance isn't changing. So what do I mean by that? Well, let's say we have dry ice. So dry ice, if you didn't know that, it is basically solid carbon dioxide. And most of you guys have seen dry ice on YouTube videos, uh, or you've seen it in real life, where the dry ice basically instantly turns into gas, and this is a process known as sublimation. But during the sublimation process, and what's in parentheses, this means solid, and this means gas. So notice that carbon dioxide is still carbon dioxide, but just the state of matter is changing. So up here, this is let me change colors here. So this is a chemical change, whereas this one here is a physical change. So the state of matter changes here, but not the compound. So no bonds are broken or reformed during a physical change, whereas in chemical changes, uh, bonds are broken and reformed. Okay, so just something to keep in mind, and that'll be it for now. Okay, so now that we've talked about what chemical and physical changes are, let's do a couple examples to see if you can properly identify them. So let's say we have iron, nails, rusting. So is this a chemical or a physical change? Um, when you're looking at things like this, like descriptions, you want to think about, are you forming compounds, or bonds being broken, or new bonds being formed? If you think about iron rusting, remember iron will interact with oxygen in the air to make a new compound, iron oxide. And because there's a new compound being made here, and because new bonds are being formed, and the bonds of oxygen gas are being broken so it can combine with iron atoms, this is an example of a chemical change. But let's say we're looking at something like boiling water. Now, we still ask ourselves the same kind of questions in terms of whether or not bonds are being broken and reformed. If you think about it, when water boils, basically we're going from the liquid state to the gaseous state. So even though we call this steam, that's still the gaseous form of H2O. So we have H2O over here, and we basically have H2O over here. And notice again, no bonds are being broken or formed. Just the state of matter is changed. And so this is an example of a physical change. Another example, for instance, would be paper ripping. So with this one is a little bit harder to tell, but when you rip paper, are bonds being broken and reformed? And you could argue that there are some connections being broken, but by virtue of ripping the paper, are you creating new compounds? And the answer to that would be no. It's paper to start with. It's still paper when you're done. It's just that the size of the paper sheet is changing. But no real new compounds are being formed through that process. So this one would be an example of a physical change. Oops, I spelled physical wrong. Physical change. What about digestion? So if we think about digestion, this is the breakdown of food, and clearly bonds are being broken and reformed as the sugars and the carbohydrates and sugars and protein and fats and all other kinds of compounds are being broken down into smaller things. Energy is collected, and this is clearly an example of a chemical change. So hopefully with these examples you have a decent idea or have a process in terms of how to determine whether a physical or chemical change is taking state. And you'll get some more practice in the homework. And that's all.